OSI, Open Systems Interconnection, is a conceptual model that describes the communication process between two devices in a network. It consists of 7 layers, each with its own set of functions and protocols that enable communication between devices. Physical layer. This layer defines the physical characteristics of the network, including the type of cabling, connectors, and signaling used to transmit data. Data link layer. This layer is responsible for transmitting data frames over the physical layer, ensuring that data is transmitted without errors and in the correct sequence. Network layer. This layer provides logical addressing and routing of data between networks. It also determines the best path for data to travel between devices. Transport layer. This layer ensures the reliable and efficient transmission of data between devices. It breaks down large messages into smaller packets and reassembles them at the receiving end. Session layer. This layer establishes and manages communication sessions between devices, including authentication and encryption of data. Presentation layer. This layer is responsible for translating data into a format that can be understood by the receiving device. It also handles encryption and decryption of data. Application layer. This layer provides services and interfaces to applications that allow them to access the network. It includes protocols such as HTTP, FTP, and SMTP. The OSI model is used as a reference framework for designing and implementing network protocols and systems. It enables developers to create interoperable network devices and applications that can communicate with each other regardless of the underlying hardware and software. The physical layer is the first layer in the OSI, Open Systems Interconnection, model, responsible for the transmission and reception of raw bit streams over a physical medium, such as copper or fiber optic cable. It defines the electrical, mechanical, and functional characteristics required to establish and maintain a physical link between two devices. The physical layer is concerned with the following aspects of network communication. Data encoding. The physical layer converts the digital data generated by the higher layers of the OSI model into a format that can be transmitted over the physical medium. Different encoding schemes are used depending on the type of medium being used, such as Manchester encoding, 4B, 5B encoding, or NRZ, non-return to zero, encoding. Signaling. The physical layer defines the rules for signaling between devices over the physical medium. This includes determining the voltage levels and timing of signals, and ensuring that devices can distinguish between ones and zeros in the data stream. Transmission mode. The physical layer determines the direction and timing of data transmission over the physical medium. It can be simplex, half-duplex, or full duplex, depending on whether data can be transmitted in only one direction or both directions simultaneously. Medium. The physical layer defines the characteristics of the physical medium used for data transmission, such as its type, speed, and distance limitations. This includes copper wire, fiber optic cable, or wireless radio frequencies. Connector. The physical layer defines the type of connector used to attach devices to the physical medium, such as RJ45 connectors for Ethernet networks, or BNC connectors for coaxial cables. Overall, the physical layer is responsible for establishing and maintaining a physical link between devices, ensuring that data is transmitted accurately and efficiently over the physical medium. It is the foundation of network communication, providing the basic framework for higher layers to build upon.